So when I wanted to make curves in my computer graphics, which was actually a Unity video game, I ended up what I thought was the Bezier curve. But I learned that I was completely wrong because the dictionary told me
Bezier.
that it's a Bezier curve. And Wikipedia actually told me the same thing is pronounced Bezier. So this is curves that we use in computer graphics, and it works by putting in control points. And in this picture we see there's 4 control points. Point 0 is the beginning of the curve, and the last point, point 3, is the end of the curve. And then point 1 and 2 are control points that, depending on where they are, that changes, of course, the shape and how the curve looks. So there's a few different types of Bezier curves. There's linear Bezier curves, which is just between 2 points. And of course that makes a straight line. And then there's quadratic Bezier curves, which has 3 control points. And then there's cubic Bezier curves, which has 4 control points. And so obviously the one that we've seen here is a cubic Bezier curve with 4 control points. But we're going to take a look at the App Guru's blog post here on Bezier curves. And I put a link to this in the description. Really great blog post about Bezier curves in Unity. And we can see that the linear Bezier curve has 2 points. And that means that we have a straight line. So this is the equivalent of linear interpolation. So we, first of all, will look at that. But then there's quadratic Bezier curves, which has 3 control points, beginning of the curve, the end of the curve. But then there's a control point that allows you to change and actually introduce a curve to the curve. But the other kind is the cubic Bezier curve, and that is 4 control points, 1, 2, 3, 4, and that allows you to, of course, have an even more bendy curve than you could with a single control point or a quadratic Bezier curve. So let's look at this first one. We're going to draw a Bezier curve in Unity, and I'm using Unity 5.6 here. I'm going to create an empty game object, and let me just call this Bezier. I'm going to add a component to it, and that is a line renderer. The line renderer is a really nice component that just lets you draw a line. You can set the width. You could set the points. So if I set this to 5, of course it would be a long line, and then I could add 50, and there would be a whole bunch of different points. Or maybe I just want 3, and I can obviously draw a line all over the place with a whole bunch of different points. And I don't want to do this by hand. I want to do it with a script. So I'm going to add a brand new component, and we're going to type in Bezier, and for some reason that says Bezier. Must be a language I don't know. And then I'm going to say new script, create and add. Luckily, I do know some C#, so at least I can speak that language. And so we are here in Microsoft Visual Studio. Now, we're going to have to make a function for this. And what the function is going to return is a point along the curve. And as we draw a curve, let's say we wanted to draw over time, we would need to then calculate a bunch of different points over time, and just as is being done here. Now there's 3 variables involved. We have 2 control points, which is P0 and P1, and then we have T, which represents time. Now time is a variable, or T is a variable that goes between 0 and 1, and it represents where along the curve the point is at. So T of equal to 0 would be at the very beginning where there's no curve at all, And with a t of equal to 1, the curve is fully completed and you are all the way at point 1. And the same goes for the quadratic and cubic Bezier curves. You could see that it doesn't matter how many control points you have, t will always equal 0 at the beginning of the curve, and at the end of the curve it will be equal to 1. So this function is going to determine a point in space that is along the curve. That means that it will return a vector 3. So I'm going to make a private vector 3, and we're going to call this calculate linear Bezier point. And this function will take a float, which is t. It will take a vector 3 point 0, and it will also take a vector 3.1. Now, what this function returns, well, we could look at Wikipedia for the formula, and over here on the App Gurus, we'll see that the formula for the linear interpolation can be written like this. So I'm going to copy this, and let me paste this into here just as a comment so I can reference it. Now p, that is going to be the point, so that's what we're returning. So I have to say return 0.0 plus t times 0.1 minus 0.0, and that is it. That's exactly matches this up. So now we have a function that, given t and 2 points, we can calculate the point along the curve. Now, in order to draw the curve, we're going to use the line renderer. So the first thing that I'm going to do is make a public line renderer, and I'm going to call that line renderer. Now, because it's public, I'm going to need to assign that in the inspector, so it should pop up here. My game object Bezier already has a line renderer, so I'm going to drag that right onto here. So now we've already populated the line renderer variable, and we're ready to put it to use. So the next thing we're going to need is the positions, and we're going to have a private vector 3 array of positions. And the reason why is you can see that there is already an array of positions here, and I don't want to populate these by hand. We're going to do it by script. So that's why I'm going to make a vector 3 array, and they're going to be filled up with, of course, these vector 3 values. So I'm going to make an array of vector 3 called positions. And we're also going to need to set how many of points there are in the line. Right now there's just 2 points, which makes a straight line, but since we're making curves, I'm going to want quite a few points. So I'm going to make a private integer, and I'll call it number of points, and we'll set that equal to 50. So there's going to be 50 points on the line, and because if I were to make this line render have 50 points, just like this, we can see we need an array of 50 vector 3s. So we're going to define that now. I'm going to say the private vector 3 positions is equal to a new vector 3 array, and it is a length of 50. So that just matches the number of points. And when the script starts, we're going to have to tell the line renderer how many points it has. Now, in the past, we would say set vertex count, and then we would pass in the integer of number of points, which is 50, and that would work, but that's actually depreciated now. So now we use line renderer dot position count, and we're going to set the position count to the number of points. So this is an older version of Unity. We don't need that. But now we're going to set the number of the position count to the number of points, so it's 50. And if we were to start the program, we should see it does set it to 50. All right, so everything is good. And the next thing that I want to do is draw a linear curve. The problem is that function doesn't exist yet, so let's go ahead and write it. I'm going to make a private. It'll return void, and it's called draw linear curve. So what we want to do here is draw the entire curve in one frame. And depending on your game, you may want to draw the curve over time, like it shows here. You can see the curve is being drawn over time. But I'm going to draw it all in one frame, which means that t we're going to have to calculate in a for loop. And so the first thing I need to do is make a for loop, and we're going to say for integer I is equal to 0. And then we're going to say I plus plus, or I is less than the number of points, so 50. So it's going to loop through this 50 times, and then we're going to do an I plus plus. All right, so now we have a loop that's going to go through and run this 50 times. And each time this loops, we're going to calculate a point, and then we're going to set that point on the line renderer. We need to calculate t, which is a float, so we're going to say float t is equal to, and what t is going to be equal to is I divided by the number of points. And if we think about that really quick, so the problem here is the first time this runs, I is 0, so now we're dividing by 0, and that's no good. So what we're going to do here is increase I to 1, so that it starts at 1. So the first time this runs is going to be 1 divided by 50, which is 0.02. And then the second time it runs is going to be 2 divided by 50, which is 0.04. And then it's going to slowly go up until it's 50 divided by 50, which is 1. So you can see that this is doing what we need to with t, which is it's making it go from 0 to 1. We just have a float value that's going from 0 to 1, and that's what we've created here by doing I divided by number of points. There is a problem with this, and I'm going to show why really quick. We're going to do a debug.log, and we're going to say I. So it's just going to log how many times the loop is running, and let's hit play. And we can see that it went all the way up from 1 to 49. But it didn't go to 50. So we got to fix that real quick. And the reason why is because we're not starting at 0, and it's saying I is less than 50. Well, less than 50 is 49. So it's going from 1 to 49. So we need to say I is less than the number of points plus 1. And that way the loop is actually going to run 50 times. So now we're ready to, now that we have t, we're ready to calculate our Bezier point. Now the vector 3 that gets calculated, we want to move it into this array of positions because this is what the line renderer is going to look at. So what I'm going to do is just say positions, and then I'm going to say I. So the first time this runs, it's going to be 0. It's actually 1. The first time it runs, it's going to be 1. So that's the same as saying positions 1. And arrays are 0-based, which means that the first value of this array will never get set because I begins at 1. So I'm actually going to say I minus 1. And that actually gets me to the first time this runs, it'll be at 0, which is the first array element, or the first array index. So the position of I minus 1, we're going to want to set that to a vector 3, and of course we could just call calculate linear Bezier point. So I'm going to pass in the float t. All right, we've already figured that one out, And now I need to pass in two vector 3's, 0.0 and 0.1. And I don't have those, so just to make things easy, I'm going to make a public transform. I'm going to call it 0. And I'm going to make another one of those called 0.1. And so now what's going to happen is just regular old Unity work. We're making a game object called 0. We'll give it a little icon so that we could see it in the editor. And then I'm going to duplicate that. And that one's going to be called 0.1. And we'll move those apart from each other. I want them to be facing the they're facing the camera. So 0 we want over here on this side. And then 0.1, we're going to move it over here. All right, we've got 2 points. And we'll get the sun out of the way. So we already know t, and we have 0 and 0.1. And going back to this, we can see we have all 3 variables that we need. All right, that means we're about to draw a line, because when we call our function here, calculate linear Bezier point, we need to pass in a vector 3.0. Well, I could call 0, and this is a transform, so I'm going to have to say 0 dot position to get its vector 3, and then we're going to say 0.1 dot position. Poison 0.1 dot position. All right. So what we have done here is we've populated this whole array 50 times 50 variables with a point along the Bezier curve. And the last thing that we're going to have to do is draw it. So we're going to say line render dot positions. Set positions, that is. And set positions needs a vector 3 array of positions. Luckily, we've already made a vector 3 array of positions, and it's called positions. So we're setting the line render's positions to this vector 3. And when we start the script, it's going to say draw linear curve, which is going to do this and calculate the linear Bezier point. And let's see what happens in Unity. I'm going to press play. And we have errors because we have unassigned references. That would be expected. We put 2 public point transforms that we did not populate. I'm going to drag 0 into place, 0.1 into place, and hit play. And we have something which is very funny looking. And there's going to be one last change to the script. Let's go over to the script. And the problem is going to be right here. We've made a float, t, and we're doing I divided by number of points, and number of points is an integer. So I'm going to cast that to a float so that number of points is treated as a float, not an integer. And I'm going to go back into Unity now and press play. And there we go. We've got our nice curve. I don't know why this is called a curve, because it's a straight line. But this is what you call a linear Bezier curve. And you can see all the points it's determined through here. And we could go into the scene and see that it goes between there, and there's 50 points. Now, if there was a curve, it'd be a nice smooth curve because there's 50 points. But because it's just a line, you couldn't tell the difference between 2 points and 50 points. But there are 50. That's good for when you actually have a curve. The last thing I want to point out is that it begins at this diamond where the diamond starts. However, it ends halfway through the next diamond. And I just want to explain why, because when we calculate the linear Bezier point, the very first time this runs, it is at 1. So it comes through and it does 1 divided by 50. So 1 divided by 50 is 0.02. So the very first point on this is 0.02 into the the line. It's not exactly at 0. So we really would need for 50 points, we would need 51. That way there was one precisely at 0 and there was one precisely at 1. But you can see what happens is the first time it runs, it's 0.2. So it's a little bit into it. So you can see it starts at the diamond. And then as it goes through there, it gets all the way up to 50. And then it's doing 50 divided by 50, which is giving us 1. And a progress of 1 is completely at the end. So the line goes completely to the end, which happens to be right in the middle of that game object, right in the middle of the vector 3 transform position. However, we're not starting in the very middle of the first one. And again, the reason why is the first time this loop runs, we're starting at 1. And so we're going up. We've already started at 1 divided by 50, which is 0.2. So we've never actually drawn any points at 0 itself. So in the next 2 videos, we're going to be expanding on this, and we're going to be drawing the cubic and the quadratic Bezier curves. The next one, of course, we're doing the quadratic, where we're adding in 1 control point. And then after that, we'll be doing the cubic, where we have the other control points. So thanks for watching. Don't forget to like, subscribe. That helps out the channel. I appreciate that. You guys are awesome. Keep coding, and I'll see you in the next cubic, quadratic, Bezier curve video.